Okay, time for another fast math class. This one is on midpoints, and if you might remember, a midpoint is halfway between a segment. So if I draw a line segment, I get something like that, and the midpoint would be right in the middle of this thing. And GeoGebra actually has a thing that says, give me a midpoint. So I can click on this, and it'll tell me, boom, right there's the midpoint. One of the cool things too is if I move it around, it automatically calculates where that midpoint is. Now that's all well and good, except I want to be even cooler and look at the midpoint of a triangle. So let's drop a triangle onto GeoGebra. A, B, C, we'll go back to the beginning. And there's just a triangle. And if we look at the midpoint of two sides, some interesting things start to show up. So I'm going to look at the midpoint of AB and AC. So these 2 points here. And let me go ahead and connect them with a segment. One of the things that you'll see is ED is actually parallel to CB. So these two lines are parallel. And in fact, the length of ED is 1/2 of the length of CB. And I think, oops, let go. The joys. This is a real polished thing. I think you can actually have it show you how, what did I do? Go back, there it is. Okay. I think you can actually tell it to say, hey, show me the length of this thing. Let me see if I can do that real quick. Show label, and I'm going to show the value. So 3.6, there we go. And I click on this one, and I set the value, which is actually the length, 7.1. So, and I assume that's just a rounding error. So if I move stuff around, notice how these things stay parallel, and 10 and 5. And even if I move this around, it's still, look at that. It doesn't even, it doesn't, like the lengths don't even change, right? So it's always 5, even if I go way out here, or even if I go way down there. That to me is really cool. But even cooler is if we drop the midpoint onto this guy here, and let me just slap that on there. And watch what happens when I connect these segments. So this segment and that segment, those are parallel. So A, B, and E, F here, I guess. And here I'm connecting these segments. And then check this out. All of a sudden, I have 4 congruent triangles. So this one would fold over into that, and this one would spin into these two. And all of a sudden, all 4 triangles are identical, which is so cool. And even if you shift them and change them, all 4 still stay congruent, which to me is just so cool. I wonder if there's a way I can make a triangle and then just shift it around. Let me see if I can do that. I'm giving you sound effects. All right, let's click on it and move. Oh, it doesn't want to move. Rats. All right, well, maybe someday I could figure that out. But anyway, yeah, it kind of makes it easier to see, I think, with a different color. So there you go. That's the midpoint theories for every triangle, actually, out there. The lines are parallel. The distance is exactly half of what the base of the triangle is. Next, we'll look at some cool things about trapezoids. But that's it for now.